Welcome, everybody. Thanks for taking the time to attend our webinar today. Basically, what we're going to try to do today is to share with you some of the field experience we have had working with devices on the field and how we have been managing and solving the problem of integrating them in cloud backends or the backends of IoT solutions. Primarily responsible for the technical solution design and project delivery for our customers in Switzerland, where we have had the opportunity to work with large-scale IoT projects in the area of automotive, in the area of medical devices, and also in the area of industrial automation. So we have seen on the field things from very small devices that need to be integrated to an IoT backend, predominantly in the cloud using Microsoft Azure, all the way to the connection of industrial equipment or plants or manufacturing equipment to a processing backend for IoT purposes. We only have 30 minutes today, so as much as we have learned a couple of very important lessons on our projects and field experience, I want to talk to you about one thing today that is relevant for field gateways, and that is the retrofitting problem. So I don't know if many of you are familiar with the term retrofitting problem, but primarily what that means in our projects is that typically organizations, when they decide to invest in IoT solutions, they realize that their current installed base of devices, equipment, manufacturing facilities or plants, whatever that might be, was not really designed for modern communication with a backend system. So we're talking about either devices that only implement very old and legacy communication protocols. We are talking about devices that were designed and manufactured 10 years ago, 15 years ago, if not more. These are devices that still generate a lot of data that is very valuable to be captured and processed in a central way, but they don't offer a standard, secure, reliable interconnection interface so that they can transmit data to a cloud backend. And this is what we call the retrofitting problem. How do you fit older equipment and older devices so that they can connect to an IoT cloud-based backend in a reliable, secure way? So what we find with customers most of the times is that when they decide to invest in IoT, and they realize they have this problem, they take the decision of ignoring their currently installed base. And they decide, okay, so we're going to invest on this IoT project for the devices of the future. But that means the devices of the present are not going to be able to leverage the investment that the organization is going to make in IoT. And this is, in our experience, a big mistake. It's a big mistake because you will be investing money, time, and people's resources effectively, building something that none of your current existing devices are going to be able to benefit from. The value of your project, if you do that, you will the time to value is going to be measured in years. And if you go to your business owners, to your business managers, somebody like a chief financial officer or chief operating officer with an IoT proposal, and effectively you explain to that person that it's going to take years for the organization to derive value from that investment, most likely your business case or your project is going to get shut down very quickly. So one of the things that we want to tell you today is that yes, it is hard to make older devices compatible with modern IoT solutions, but this is a problem that really needs to be solved. It has been solved, and please don't neglect your older install base because that will make the value of your IoT justify. Which takes us to the question, well, okay, so there's a retrofitting problem. How do we solve it? And there are multiple ways to do that. And one of the ways that we have found most effective to do that is by using gateways or field gateways. So what is a field gateway? Effectively, if you look at the slide I am sharing right now, If you move from the boxes from left to right, you will see that the devices, it all starts with the device. Whatever that device is, whatever generation that device is, this is the entity that generates the data. And then you will move to the gateway box, which is highlighted in green, which is a device you put in the field that is able to integrate and understand how to talk to these older devices, but at the same time is in a capacity to understand how to talk to central cloud-based IoT backends and do the translation for you. And I'm going to go into detail later on what that means. And once you go into the ingestion box, that's effectively where you receive the data. Then you can process the data. You can feed the data to big data solutions or machine learning models. You can visualize the data on a reporting dashboard, whatever that might be. But you need to find a reliable way to bring the data from the devices all the way to the ingestion point, most likely in the cloud, but not necessarily. And for this, we have seen that doing that with field gateways, you will be able to accelerate the onboarding of your devices, which also means you will accelerate the time it takes for your IoT investment to deliver value back to the organization. When I talk about gateways, people, or field gateways in particular, people typically think about a box that you put somewhere. That is most likely the case, but at this point of time, I want you to think about gateways not as physical hardware devices. I want you to think about them as software, and you will see later on why this distinction is important. Why is a field gateway important in any case? So why not modernize the equipment itself so that it understands modern communication protocols? Why use a field gateway in general? So these statistics come from a study done by IDC, if I'm not mistaken. This applies mostly to industrial automation, but in my experience, it pretty much applies to most of the industries I have personally worked with. 85% of devices out in the field are not internet ready. So that means they don't understand modern communication protocols. They don't understand how to do credential management in a proper way. They don't understand modern, reliable encryption technologies. They don't understand any of these. They are pretty much designed to provide a functionality. They do maybe implement some communication interfaces, but not something that you would trust to communicate through an internet channel, through an unsecure channel like the internet is. Also, it's important for you to understand that if you are in a position to do edge processing, so if you can take the data from your devices and do some initial processing at the edge, on the field, and not on the cloud, you can achieve up to 60% reduction on your cloud costs. And this is really important because we see customers, when they start their first exercises in the cloud, they transmit all the data. We have customers that send data to the cloud every second, and they send very big data models. We've seen people send data every 100 milliseconds. There's a lot of data that is being sent because the device doesn't understand yet how to filter data before it is being sent to the cloud. And if you send everything to the cloud, you're going to have to pay a lot of money in terms of transmission costs, storage costs, and processing costs. So if you have the capability of pre-processing the data in the field, you will be able to achieve significant savings in your IoT operating cost. There's also the topic of network optimization. So if every single one of your devices connects to the cloud, I don't know, depending on your scenario, maybe you have devices that are just standalone by themselves. Maybe you have multiple devices in the same physical location. For example, that would be the case for a manufacturing facility. But if you work in the second scenario, if you use a field gateway, you will have the possibility to use features like batching of messages, of compressing messages. You will be able to do something that we call message composition, which is where you take a message from one device and you merge it with messages from other devices to create one single composed message that you need in order to do analytics. You can also do things like queuing the messages so that you make sure if the network connection on the field is interrupted, you still receive the messages on the field gateway. The gateway queues those messages, persists them in memory or maybe in disk, and when the network connection is reestablished, then all the messages that were in queue are transmitted, so you don't lose any data. You can also look at throttling capabilities, which is when maybe you have limited bandwidth and you may have a lot of devices sending data to the cloud, but you want to manage, optimize the network utilization using throttling at the gateway level. It's also very important that the gateway gives you a consistent implementation of infrastructure capability. So if you tell your development teams to adapt every single device to make it cloud ready, then every team is going to have a different security implementation. Every team is going to manage the credentials in a different way. Everybody's going to do the same things in a different way. Whereas if you give them the option of simply integrating with a field gateway, all of these infrastructure plumbing capabilities will be done in the same consistent way. So this is in a nutshell why we see that it's important to use field gateways to solve the retrofitting problem on the field. One thing that's also important is that all this infrastructure plumbing things is not really something that adds value to your business. So things like handling messages, implementing transport protocols like HTTPS to communicate to the cloud, or AMQP or MQTT, these protocol implementations, these things take time. Implementing the way how to manage credentials on the field so that your devices can authenticate in a secure manner to your IoT backend. Implementing health and reporting, health and diagnostics capabilities. How do you monitor that your devices are working okay? How do you monitor CPU utilization and memory? How do you persist messages? These are all things that are not trivial to implement, that are required. However, they are required to have a reliable IoT environment. But these are not things that per se give value to your business. And yet, if you realize you will spend a lot of development time in getting these things done. Instead of doing all of that, you should be spending your development time and resources doing things that generate value for your organization. So that means investing time in implementing edge analytics. Again, maybe you don't want to send all the data from every device all the time. Maybe you want to implement some rules to generate alarms based on some thresholds or similar things, and push those rules over to the field and make your devices act on those rules and send only the data to the cloud that you care of. You might want to spend time on implementing your own protocols. If you have some proprietary protocols defined within your organization, then you will have to implement them. And also implementing your own business logic modules. These three things are the things that add value to your organization, and is where you should invest your development time and resources on. If you connect your devices through a field gateway, you will see that most of the things on the red box are already offered out of the box for you. And you can spend the time not on those trivial infrastructure topics, but rather on things that really add value to your business. In this regards, then it's important to ask, if you go out to the market and look for a field gateway, if you have a retrofitting problem to solve, and you do agree that the best way to do that is by using a field gateway, then what should the field gateway offer you? And this is the reason why I asked you earlier to think about the field gateway not as a hardware box, but rather as a software component. I was at the Hanover fair for industrial automation last week, and you will see many companies that offer field gateways. And some of those gateways are little boxes that they do one thing. For example, they integrate with OPC UA protocol over to the cloud. Some of them will even offer you 300 different protocol compatibility that you can connect over to the cloud. And that's all fine, but the field gateway is much more than a box with some protocol implementation that you put on the field. The points that I am listing in this slide, we have seen that it is really important for your gateways or for your devices to be able to satisfy these conditions. The first thing is that your field gateway should also be accompanied by a cloud gateway or a backend gateway. That is a central place either on your premises or in the cloud, uh, built on an API layer that allows you to interact with your field gateway. So it's not only about the gateway sending data over to the cloud, it's also important that you can communicate back to the gateway in the central way. So that means being able to read the reported configuration that your gateways have. It means also being able to change the configuration of your field gateways from a central place without you having to send a technician to the field to do updates on the local gateway. It means being able to push software, for example, that you can update the binaries or the modules that you are running on the field without, again, having to send a technician on the field for some local intervention and so on. The second point is really important. The gateway needs to be extensible. It doesn't matter if your gateway supports 300 protocols. In the future, you will most likely face a scenario where you are going to have to develop a customization that needs to be run by the gateway. And if your gateway is a locked down black box that allows no extensibility, then that's it, game over. You may buy a field gateway today that supports all your protocols, and you deploy that on the field. Let's say you have 5,000 of devices out in the field, but maybe 2 years from now, you're going to have a different implementation or a different protocol to work with. And if the gateway is not extensible, then you will have a major problem. The third point is it's really important that you find a gateway that offers you cross-platform compatibility, but that also allows you some flexibility in which type of hardware this is going to run. So you don't want to lock yourself down on this thing only runs on Linux, this thing only runs on Windows, or what have you. You want to be able to have the flexibility in which operating systems the field gateway supports and which type of hardware it supports, so that no matter the scenario, whether you need an embedded microcontroller and put a gateway there, or you need it on a more capable server, you will be able to run the same field gateway. The third point is related to actually point number 2, which is a modular architecture. And later I'm going to show you an example of that. What does that mean? It means that your gateway, apart from being extensible, should offer you a modular architecture so that you can plug in the different modules that you need in order for your field gateway to provide you the features and the analytics that it's supposed to provide you in a way that you can plug and play different modules, that you can configure those modules individually, and you can also tell the gateway how each module communicates to the other modules and in which form. And I'm going to show an example later to make that a little bit more tangible. Point number 4 is related to actually number 1 as well. It should offer you cloud to device management interfaces. So if you do have the opportunity to work with field gateways, you should be able to manage them. You should avoid have the necessity to go on the field and manage that, but you should also avoid being locked down by something like a web portal, right? So if the way you can manage your gateways is implemented not in a fixed web portal interface, but is based on APIs, then you can build or utilize the vendor's web portal, but you could also just consume the APIs to build whatever integration you want. That might be integrating with your SAP system so that you create a service work order for a field gateway that is reporting trouble. It means that you might be able to deploy an iOS application that integrates with these cloud APIs to manage and interact with your gateways. And finally, the gateway should be able to offer you monitoring and reporting capabilities. So the gateway should be able to report to you the health and status and diagnostics of the gateway itself, disk space, CPU utilization, utilization of memory, utilization of ports and things like that. but it should also be able to tell you the health of the devices it is managing. Are the devices connected or disconnected? Are they reporting errors? Are they reporting an unreliable network connection, and so on? As an example, I want to take the Microsoft Azure IoT Gateway SDK. This is simply an illustration of what I meant earlier about being modular. This is open source. You can see the link on GitHub. You can fork it. You can do whatever you want with it. It's cross-platform. It is written in C, and it's very easy to customize because it allows you to plug in different modules, like I mentioned before. For instance, if you look at this picture and you move from left to right, the protocol ingestion module is the one that integrates with your devices in whatever protocol your devices understand. There is also a filter module that filters the message based on properties that you think are important to process further or ignore. Then you will have an identity mapping module, a login module, and eventually the module that sends messages to the cloud. This is just conceptual. You might have all these modules, you might have more modules, less modules. This is just, I just want you to understand from an architecture perspective, it's important that your gateway is compatible with a modular concept. In the case of the Microsoft SDK, you can see, for example, that you can configure the gateway using a simple JSON file. For instance, take a look at the boxes in red. So you will see that there is a module called node_printer, and the bits for that is a JavaScript file. So this is implemented in Node.js. You can see on the second box on the bottom, there's a logger module with a .so extension. So that's a shared object. This is implemented in C. So the same module can run, the same gateway can run modules written in .NET, in JavaScript, in Java, in C. You pick the language that your teams work best with, and then you plug in these modules into your gateway architecture. And if you look at the box on the right, you will see how all this is orchestrated. So the source BLE, which is a Bluetooth device, sends data to the filter module. The filter module sends data to the mapping module to the IoT hub module, and all the data sent by all modules is captured by the logger. So very simple to say how each module talks to each other. So the key takeaways for this session: please don't neglect your currently installed value from that, all those older devices you have in the field. Field gateways are great solutions to solve the retrofitting problem. In fact, my personal opinion and the reason why I'm here today is to tell you this is probably the easiest and fastest way that you can find out in the market to solve the retrofitting problems. Look for a modular gateway that allows extensibility. This is really, really important. And don't only focus on protocol compatibility and protocol extensibility. Look at also having the capability to extend the gateway with things like edge analytics. Look for gateways that provide robust infrastructure features like the centralized management by an API layer that allow you to prevent the data loss in terms of transient network failure, for example. They give you the opportunity to distribute software from a central cloud location over to the field. Invest your time in tasks that generate business value instead of investing your development team's time in things that are trivial infrastructure topics. If you want to know more about this, I would recommend, first of all, to get your hands dirty. Download the Gateway SDK, implement your own protocols, connect them to the cloud, see how it looks like, and you'll start getting ideas about how to use that same concept to integrate your own devices. We at Codit have developed on top of the Microsoft Gateway SDK our own end-to-end gateway solution, which implements the concept that I've been talking about. You can learn more about that on the URL over there, nebulous-iot.com. And finally, if you're interested about our additional experiences and lessons learned we have accumulated from the field, I will encourage you to visit our blog where I've written a post. It's there, Internet of Things, discover the 4 maturity levels, where we share with the public some additional learnings from our field projects.